NuPIC. This is Matt Taylor, NuPIC open source community flag bearer. I am going to talk today about the NuMinta geospatial tracking application. And this is a NuPIC application that will take geospatial information, plot it on a map, and do anomaly indications on every point in the route that's passed in, and give you a plot on a map of the anomaly score or indication for each point in the routes. So I'm looking right now at the repository. It is on GitHub under NuPIC, or excuse me, under NuMinta/NuPIC.geospatial. So you do have to have NuPIC installed to do anything useful with this application. It is a Python application, so there are some dependencies that you can pretty easily install with pip. And to use it, you simply run the server. So when you clone this repo or download it, it comes already canned with some sample data. So I'm going to show you that first. So here I am in my shell under this repository, and I'm just going to run Python server. That's going to start a local web server on localhost. And it's going to load up that sample data that's already been processed with NuPIC, and it's showing you the results after NuPIC has done anomaly detection on these routes. So I'm going to walk through this. There are 4 routes in this sample data set. The first one is a drive from Sunnyvale up to Redwood City, and it's all red because it is very anomalous. So keep in mind, this is a brand new NuPIC model. It's never seen any data of any kind before, so it is a high anomaly score for every point along the route. So we've done this route several times. So this is the second pass on the route, and as you can see, there's a kind of gradient from green to red that indicates how anomalous each point in the route is, or how anomalous NuPIC thinks each point in the route is. So in the second pass, it still has some high anomalies in the beginning, but it gets better. And then let's look further along at the third track. Here we go, which is almost entirely green. So it is used to this track at this point, this sequence of points. And then the last one, it's almost entirely green, but there's a point here right in the middle that is anomalous. Let's take a quick look at that. And there's a reason for that. That's because whoever was driving this car and tracking their GPS location took a bit of a detour and made an exit on Embarcadero Road, did a U-turn, and got back on the highway. So as you can see, this is anomalous behavior based on previous routes, and NuPIC does pick it up as an anomaly along this route. But once the car got back on the highway, started heading back up, the anomalies went away, because that is an expected behavior. It's a behavior that has been seen before. So that's the sample data that comes preloaded with this demo application. If you want to just open it and run Python server and see this, you don't even have to have NuPIC installed for it. But if you want to do anything interesting, you do have to have NuPIC installed. So there is another portion of this application, and it's at simulate is the URL, just /simulate. And there is a route simulator here, which is kind of neat. So you can make your own routes, essentially. So I can simulate some route between point A and point B, and then tell it I'm going to do 4 trips along this route. If I click the build button, this will actually pass this through NuPIC, encode all of these locations using the geospatial coordinate encoder, and create a model and pass all that data into NuPIC. And the result will be a display of the results from NuPIC on how anomalous it thinks each track is. So here is the result from the simulator. This is the entire track, it seems. You can kind of peruse through here with these buttons, or this slider down at the bottom, and see there's a lot of points along this. So There we go. You see parts of the route. You can kind of slide along and see as the object or whatever it is moving from place to place. Instead of using the simulator to immediately analyze this or push it through NuPIC and get a result, you can also just save that track out to a CSV file, which that can be then used later to run through NuPIC from the command line and then start the server with that data to be displayed. So those are two ways to do it. How to do that is all defined in the README. I'm going to go over how to load your own GPS tracks, but details about how to use the route simulator are also in the README. Okay, so let's talk about GPS information that you could get from your own devices. So if you've got Android or iPhone, there are some applications available for getting data, GPS data. The one I used was called GPS Kit. It's a pretty decent application. Cost $10, so that's a bit of a bummer, but it was worth it to me to do this. So that has a feature where you can track yourself. However, you can create as many tracks as you want, and then export it into GPX format, which I'll talk about in just a minute. There's also an app called a GPS Logger for Android. I have not tried this, but it does advertise that it can export GPX format. The GPX format itself is just an XML format for location information. We can take a quick look at this just to kind of show you what it looks like. So here's a sample GPX file. It's just XML. It's got tracks. Tracks have segments, and segments have points. Each one can have an elevation, a time, and a latitude and longitude. So that's what a GPX file looks like, and that's what we're going to be dealing with when I tell you how to get your GPS information into this geospatial tracking application. So I have a bunch of GPX files that I collected with GPX Kit for iPhone, and here is one example of this. This is my dog walking route. So this is typically what I do every day. I take the same route every day. And we're going to take this GPX information. I'm plotting this in Google Earth right now, which plots GPX files. And we're going to take this data and we're going to pass it through the NuPIC Geospatial application. And I'm going to show you how to do that right now. So let's kill the server, clear this out. So I have my walk data in a file called data/walks. So here are all my GPX files. So as you can see, they're dated here. So here's my walk, Friday, Thursday, Tuesday, Wednesday, and these are the files that we're going to display and analyze. So there is a tool that will convert this GPX data into a format that NuPIC Geospatial can read. It's in Tools. It's called Convert GPX. And I just point it to the directory where my GPX files are. And it creates an output file. So it created output file and output walks. And I can add a few options to this. I can say verbose, I can say output temp or something like that. Or maybe not output temp. I don't know if that's a proper option, but sorry. But I can say output verbose and it'll tell me here's what I'm reading, here's the tracks that I'm processing. So it will actually look through all of the GPX files that are in that directory and break out every single track, because one GPX file can have many tracks, and create an output format that has them separated by track. So that's what I've done, and my file is in output walks.csv. The next step, and this is all in the README like I said, is I want to run this CSV file through NuPIC Geospatial. So what this run step will do, and there's several options that you can specify here. The only option I'm going to use is manual sequence. So let's do, and I'll explain what this is in just a moment. Output walks CSV -m. So if you do not specify -m, the logic in NuPIC Geospatial will break up sequences for you automatically based on a couple of different factors, one of them being time deltas. So if it sees one long GPS file or one long track or coordinate information, and it sees big gaps between portions of it, it will assume that those are sequences, and it will tell NuPIC to reset itself between those, kind of learning each one as its own sequence. I don't want it to do that because every one of my tracks is just one dog walking route. So I'm going to tell it -m. That means I've manually already segregated up my tracks, and the GPX conversion process does that for you. So I'm going to tell it to do it manually, and now it is going to run those all through NuPIC. So NuPIC is actually running right now. We get a couple of debug statements coming out of there. If you want to see some more details, you can run it with verbose, and you'll see a ton of stuff flowing through the screen. So you can see that it's actually doing something. So it says that you do get a CSV file with the anomaly scores if you want to look at the data in something else, but it also creates this JavaScript data file, and that's the file that gets displayed by the web application. So at this point, this data has been converted, it's ready to be viewed, the anomaly scores are already populated. We just have to start the server once again. Python server. And let's take another look at this now with my data, not the canned data. So I think I had 3 routes in here. And I'm going to go to the first one. So just like you saw in the other demonstration, the first route is usually pretty anomalous because it's never seen anything before. So start it off here, and you can there are some controls down here so that you can track along with the route and see at each point where exactly what color it is. So that's the first route, entirely anomalous. Let's move ahead, try and find the second route. There we go. This one is not so anomalous, but still anomalous. If you'll notice, I can show these at the same time. My second route, I kind of took this weird dog leg off to the side here because one of my dogs had done their business down here, and I knew there was a dumpster on this little dog leg, so I don't like to walk with a bag full of dog feces, so I decided to dump it off at the dumpster. And you can see there's a bit of an anomaly there because it's not something that it saw the first track. There are some other anomalies along other parts of the route, and the thing is, my dogs have typical places where they'll stop and do their business, but it's not always exactly the same place on every walk, so that could be because of that. So going ahead to the third track, there it is. This one's getting a lot better, so no real high anomaly scores on this one, and then by the time we get to the fourth track, it's pretty smooth, pretty green. So NuPIC has a good representation of this route at this point, and that's cool. So one thing you might be wondering is, if you're familiar with NuPIC at all, is how is this input data getting encoded? So we have our own special encoder for this that's recently been developed. It's called the Geospatial Coordinate Encoder. And there's an entire video on this, so if you're interested in how this location information is being encoded and eventually converted into SDRs into NuPIC, you can watch this video of Chetan Serper, a NuMinta engineer, talking about exactly how the geospatial coordinate encoder works internally. But that is a little off topic for this. So I'm going to do a couple other interesting things. I've got another walk track that I'm going to convert now. Tools, convert. In my data, I also have a walk that is called walks reverse. So you might know what's going on here, but I'll just run it and still in output walks, and I still want to manually separate the sequences based on track name, so I'll throw that in there. And now let's start the server again. and take a look again. Okay. Okay, something's wrong. This isn't what I expected. Oh. I'm an idiot. Excuse me. When I did the run, I did it on the old walks file. It's actually called walks reverse now. So I was actually running that against the old output file. So now we're running it on the reverse file. And what this is I did one walk after all of those other walks where I did the reverse of that route because I wanted to see what NuPIC thought of that. So let's start and see what NuPIC thought of that. So the server has started, and I'm going to start with the first track again. Completely anomalous. The second one, and this looks like it's the second and the third kind of combined. So second and third are the same pretty much as last time. The fourth track is in here somewhere. I'll have to try. Oh, there it is, right there. And then a couple days later, I did this track. So if you look closely at this, I am starting in the same place, but I'm taking a left instead of a right. And that is anomalous. That is not something that NuPIC has ever seen before. So as you can see, there's decent levels of anomalies along the entire route until I get back to the bottom leg of the route when I'm heading back to the house, and that's all entirely green because that's a typical track that it's seen before. So that's something that NuPIC will definitely pick up if you're on in the exact same location as somewhere you've been before, but you're not moving in the same direction. So that is another interesting feature. And now let's do one more little experiment. I have this other one, which is I call NuPIC or walks abduction. So tools, convert. This one has an extra track that's not reverse, but it is unexpected. There we go. Okay, converted that file. Run. Output, walks, abduction, manual sequence resets. And let's take a few seconds here, and then we'll start the server again. Python server. We will see immediately what I'm doing here, but let's hide that for a sec. All right. First route, same one. The second, third, fourth routes all the same. So it's learning the same pattern basically, but I tried to trip it up on this last one. So let's go, there we go. So what I did on this one was I started out normal enough, but I got along around here, and before I left the house I said to my wife, hey honey, wait 10 minutes, come along this route that I usually walk the dogs, pick me up in the car, and drive me off somewhere. So that's what she did. So when I got to this corner, she drove up, I jumped in the car, and she drove me off to pick up one of my kids' friends or something. And then drove me back. You might note she took the same road that I always walk the dogs along, but the anomaly scores are still very high, because I'm moving at a significantly higher amount of speed. So this I call like the abduction case. So if this were something like I had attached to my daughter, and when she was walking the dogs, if we theoretically had some type of application that was live feeding GPS information from her location into NuPIC, and I was getting notified whenever there were significant anomalies, this would notify me almost immediately that something went wrong on the dog walk. So I think that's pretty interesting and could be very applicable to a lot of different scenarios or situations. So that's pretty much it. So I've gone over getting your own data files, your own GPS data into this sample application, NuPIC's geospatial tracking application. We've talked a little bit about GPX. I talked a little bit about the geospatial encoder, but like I said, if you're interested in seeing how that data is encoded, you really should check out that video about it. That goes into quite a bit of detail, and it'll probably help you understand exactly why the anomaly scores went up so high when my speed changed so dramatically on that last abduction route. So I hope you enjoyed this. If you want to play around with this, please do. I'd love to see what types of things you guys in the community come up with. There's a lot of potential applications for this type of technology. Just think about logistics trucks, deliveries, typical routes for UPS, trains, planes, whatever. All of those stuff that have typical patterns within their routes, this could be useful for live anomaly detection on any of those patterns when something goes awry during the typical workday or what have you. So thank you for watching, and I hope you guys have fun with this. It was fun to play around with. I'm really excited about it. And be sure to check out the video about the geospatial coordinate